Hey, it's W5HRO. Here's the update on this T368 exciter rack. I've gone back and redone some of my videos. This is going to be part 14, the new part 14. Uh, I started laying this stuff out. I finally got the majority of all my parts, and except for a couple little things, but I've got enough of it where I can start drilling the holes and mount everything. Start mounting it all. The first thing I did was I've already mounted this transformer because I realized too that I needed a space. This is what I'd forgotten about. I needed a space between the panel and the transformer to put the meter. And what I've chosen is I have some 2.5-inch round meters. I was going to use a 0 to 200 milliamp meter there, but then I kept going back and forth about maybe using this Heathkit DX100 meter, and that's pretty much what I've decided to use now, because it'll make it really simple. I can put the 1 ohm shunts throughout here to measure everything, and I can just mount this on the front panel right there, and I can put the selector switch below it, the switch between the shunts that are mounted in there, that are wired in there. And that'll be great. And I can actually I bought this knob. If you look at the original T368 exciter knobs, they're just one round. Well, they don't have this other part on the spinner part. Well, I added the gear reduction to this, so I changed the knob because it's got gear reduction now. Excuse me. But where I got this knob, they also sell these exact same knobs here for this. So I'm going to get one of these to put down here below the meter so it matches. So that'll look nice. And then also the other thing, somewhere years ago down the way back, I think I found these at a surplus place. I found these spot buttons that came with the Heath transmitters, like the Apache, for spotting the transmitter to the receiver. Well, I realized I need a spot button on this exciter front panel to do the same thing. So I thought, well, this transmitter is primarily made from Johnson & Collins design stuff. So why not add a little bit of Heathkit, right? I'm going to use the SB10 sideband adapter, and there's something I'd forgotten that I'm going to get back to here in a minute about that. But I thought, well, let's use a little bit of Heathkit stuff. So this will be a lighted meter, and the reason I kept going back and forth on this was see how the slot where the screwdriver goes to zero the meter is chipped a little bit. Well, I normally like to use new looking stuff on my transmitters whenever I build something like this. I don't like using, a lot of people would just use this as is, but I could probably replace that set screw. But the good thing is I got on eBay a couple days ago and somebody was selling one from a DX100B. So it looks in perfect condition as far as the front and where the threads are. I mean, the plastic, the Bakelite part looks fine. So if that meter by some chance didn't work, I can rob Peter and Paul from this. I can just take the two and build up one, but hopefully that other one will work fine and I can just put this back in the drawer. But that'll be the perfect meter for this. And I'll have the matching red spot button from the Heathkit transmitters as well. But the other thing I'd forgotten about, once I got this in here and left the space for the meter and got everything arranged like it's going to go to see how everything would fit, I realized I didn't have room for that relay. That was that solid state relay I had in there mounted on that heat sink that was going to, engage the voltage to the 3 diode negative peak limiter for the modulator. I was going to mount that other transformer here and the heat sink there. I already had the heat sink and the relay there, but then I realized I have no room for it. So what I'm going to do is, here's that relay and heat sink for that limiter supply. So what I realized is I can just mount this on the side of the cabinet right above the limiter inside the cabinet and the transmitter, and that'll be fine. That solves that problem. And I'll put the transformer someplace else. There's still plenty of room to put it somewhere else. But anyway, that's what I got to do. But I realized the thing is, what happened is, after I realized I didn't have room for that other transformer and that heat sink, it dawned on me, wait a minute. Because my original idea years ago, when I was thinking of the design of how I was going to do it, was I was going to slide this exciter all the way over this side or all the way over that side. And then I was going to shove the SB10 Heathkit sideband adapter on the other side, or this side, depending on where this was mounted. But then I realized when I set everything in here, it was not going to fit. So, okay, the SB10 adapter for sideband is going to have to remain an external box. It just plugs in the back of the transmitter, and that'll be fine. I can build the supply inside of the adapter. There's actually a spot I can mount a little transformer and just build the supply internally for it and simplify it. But once I realized I had forgotten about that, because what I have to do is that the way the transmitter is designed, right, the way my RF deck is, I've added the AB bias switch. So I have the switch on the front panel that when it's normally in default position, which is Class C phone bias, which has a grid leak resistor. When I switch to sideband, it's got to go to AB bias. It's going to switch to a separate supply to the grid of the 4400 tube, you know, to set the bias for AB for sideband operation. But when that happens, I have to be able to switch the coax output of this T368 exciter through that SB10 adapter. And I'd forgotten about that, and I realized what I was going to have to do years ago when I thought about this was I was going to have to add a couple coaxial relays or some vacuum relays, or it's just some kind of relays to switch the coax in line with the adapter and back out of line, because the way it's normally going to be is, for normal default AM uses, the output of the exciter is going to go right through a piece of coax right to the grid of the 4400 tube in the RF deck. And then, you know, that's how it was. So how are you going to get AB bias? Well, I got that selector switch and a relay that switches it to the internal supply that's going to apply the bias to the grid of the 4400 tube. But it has to switch the coaxes through. So what I can do is, I have these extra holes here from where I remove the heat sink from for that relay. And I already figured out I can use the other holes to mount the one side of these two transformers, which is perfect, see? And then I can just enlarge these holes and mount it, drill them out larger and put a couple relay sockets in there and just plug a couple relays in, and I can just do it that way. So that'll be perfect, because the way I've got the RF deck is, when I switch that switch to go to AB bias, it's also going to throw that 12 volt control when it switched to AB bias out the back of the transmitter, or out the back of the RF deck chassis. And I can plug a cable from that down to here to control these relays. So it'll just be one switch that switches this thing and the RF deck to where it needs to be to operate sideband. So that's what I'm going to do with that. And then the one last thing I have here is that I'm going to mount this today. I think my little L brackets are supposed to be here today. It's actually Sunday, believe it or not, but Amazon delivers on Sunday. I ordered a little pack of L brackets. There's more than 4, but I only need 4 for the corners, because I'm going to mount this thing on insulated standoffs. These are the heat sinks and the pass transistors that are going to, regulate this transformer down to apply the voltages here to the exciter. And what I also did was I added some little nylon standoffs on the end, because this is the heat sink to that negative supply, and the other ones are positive supplies. So I wanted to isolate, because the thing is these T03 packages on these heat sinks would normally be shorted to the heat sink. I mean, these are the cases, the collector. These things, that's where the high voltage is going to be. When this thing's powered up, when you touch your voltmeter here to the positive probe to that case, it's live, it's hot, the voltage is right on it. So I have the Mylar insulators, the spacers, to insulate the case from the heat sinks. So I thought, well, if one of those was to ever leak, say one of these 4 leaked here, and maybe this one leaked there, then it would short the collectors together from the negative and positive supplies, and that's bad. You wouldn't want that. It'd go kapowie or something, you know. And then also, if one of them did, it would short down to ground. So that's why I'm going to mount it. This is going to be mounted on insulated standoffs to isolate it from chassis ground. That way, if one of these was to, in fact, ever did short out, then it wouldn't stop working. It wouldn't blow up. It wouldn't fry things. It would just keep working. It would just make this thing live, hot. So I'll just put a warning label saying that the heat sinks on this could potentially be live. So beware. You know, high voltage could be 400 volts to ground. You know, plus or minus a little. So anyway, but that's kind of where I am on this. I've been sitting back for so many weeks waiting on parts, because a lot of this stuff came from Asia. I think these heat sinks came from China. Well, these spacers came from China. The heat sinks came from Taiwan. These BUX 48A transistors were back ordered from, I think it was DigiKey, and they took like 3 weeks to come in. And then these transformers for everything else came in really quick. These were like piece of cake. I had those within a few days' time. So that was the easy part. But everything else, for like mainly this heat sink, was the stuff I was having trouble getting. So I could put this together. I guess I could have come up with some other idea, but I'm looking at it, and to make everything fit, how else would I have done it? So I think this was the best solution, mounting this thing on some standoffs to insulate it from ground, and it's finned properly. It should work really nice. I did power up the one with about 400 some volts. I went through a couple Zeners, and I ran the pass transistor through it like normal with about I think about 150 milliamp load on it. And the heat sink got warm, but the transistor stayed nice and cool. So the heat sinks get hot before the actual transistors do. So that's a good thing. I think the heat sinks will be big enough. And the fact that I have these four shorted together via metal, but some of that heat's going to transfer through these standoffs, these gold standoffs, that's connecting it together. The heat's going to transfer to that. So it's all going to be, and it'd be nice if it did go to ground, but it's not going to work. I have to isolate it to be safe so it doesn't blow something up someday. Those things may never short out, but just say if one of them did, it's just not worth the risk. So that's just safety on my part so it doesn't blow something up. So I guess that's it for now. Is there anything else I forgot to mention? I don't think so, but it's going to be nice. I'm going to have a lighted Heath meter from a DX100 or 100B on there, or a combination of both, with the switch below it, the switch between the shunts, and I'm going to monitor the 6,000 tube plate, the screen, current plate, the current on the plate, on the screen. If I could talk straight here, and then the current, going to the multipliers and all that, how much it's drawn and how much the PTO's drawn. I'm actually going to probably measure the output of all 5 supplies. The supply for the plate, the screen on the 6,000, the supply for the multipliers, and the supply for the PTO, and then the negative. I really don't need to measure that negative grid blocking supply, but since I'm going to have, if I find a switch with enough positions, I'll go ahead and add it with the shunt too, because it'd be nice, because if something in this thing ever started leaking or something, you could see high current on that grid blocking line. But what they do is on these, I'm glad I remember this before I stopped the video, is the way these exciters work is there's a negative 55 volts that gets applied to that negative 55 volt line that's coming from that P101 connector. And what it does is it goes to the grid of all these multiplier tubes plus the 6,000 tube, not the PTO. The PTO is always on, it's always outputting its signal through this down to the input to the first multiplier tube. But what that negative 55 volts does, it's normally on there. It just pulls the multipliers and the 6,000 tube down into below cutoff, and it just keeps everything turned off so no signal goes through, or it doesn't draw any current. So it leaves the 6,000 plate voltage and screen voltage on it all the time. It's just the grid's pulled so far down negative, it's not a problem. Then what you do is when you ground that negative 55 volt line, it stops, it takes it out of the blocking mode, and then signal starts coming through the multipliers and through the 6,000 tube, and it starts drawing current. It's a pretty simple way to, transmit and not transmit PTT on and off. You just ground that negative 55 volt line and unground it. That's it. Ground it for transmit. So it's a pretty simple way to operate this thing. A lot of people do complain that they do hear the signal. This thing operates from like 1 meg to 3 something. So you're going to hear it. It depends on where you are in the 75 meter band. You'll hear it on 160. It may be, I can't remember, it may be down low enough to not mess you up on the phone part of it on 75 meters, but I can't remember. Maybe not on the AM part, the AM, where all the AM frequencies where people like to hang out, like 3880, 85, 3870, those hangouts. But anyway, some people like to put a shield over this for that reason. So I may have to do that. I may actually enclose, when this is all said and done, I may try to figure out a way to build a shield around this whole thing when it's done. But I'll have to see what it does. It may not be worth it, because if it's low enough in the 75, 80 meter band, I won't worry about it. If it's down below the phone portion, I don't care. And it'd be a problem on 160, but you know, I'll worry about that when the time comes. I primarily plan to operate 75 and 40 with it anyway, and I'm going to try 20, and I'm going to try to make this thing work on 17 meters, because these exciters do go up. They do go up to like 20 megacycles, and they actually go up a little bit higher. They'll go a little past it. I just don't know if my circuitry in my RF deck, because I have a big plate tuning capacitor, and I removed some of the plates to get the minimum C down on it, but it still could be too high for the 17 meter band, but I'm going to find out. That's my plan. My plan is to make the transmitter work from 160 up to 17 meters where the exciter goes, and that's it. So that's what I'm shooting for on this. So I think that's it. I think I've covered everything for now. So when I get everything mounted in here and start getting things, getting stuff wired up, I'll take another video, or I'll just wait till I get it powered up. I'm going to try to space out the videos now. I was doing a bunch of them in a row because I was waiting on parts and I was getting bored, and I was getting bored, and I was trying to keep people updated. So, you know how that goes. I had to have something to do, so I just did videos. But those are the ones I went back and removed because I overlapped with the same info 2 or 3 times, and I wanted to set all that straight. I know people don't like to watch 1 hour long videos, especially like 3 of them at a time. So I'm going to simplify here and just do less videos with more content. So that's it for now. It's Sunday morning here. It's a nice, cool breeze coming through, but by about noon, oh my God, it gets to like 98 degrees here. It was like just about 100 yesterday, and it's going to be probably 101 or 102 today. It's supposed to be hotter. So that's it for now. So till the next time, this is W5HR and an O.